that. Okay, so sorry. What's this? Well, I took this worksheet here, and I did put it on there, and I should have put it on yesterday. I feel kind of guilty, but I don't. You have Wednesday, Thursday, Friday. I mean, you got all week to look at this. You're really not being asked of a lot here, so hopefully you appreciate that. And I took one of them. I took this number 6 off the worksheet, and we're going to start with that. And then 7, 8, 9, or 7, 8. I thought there was a 9. That's even easier. Sketch 1 period, because we do have those right-left shifts in both of them. Close that off. So I took number 6 from that worksheet. If you wanted to go ahead and print that, go for it. We'll give you a minute. If not, just get your homework sheet out for that 4-2 worksheet. Label it 4-2 worksheet and start with 6. I'll show you what you got to do. The reason I picked it too is that weird pi over 2. I know some people asked how I printed this, so they're ready to go with it. Tried to limit the amount of printing, but we can only do what we can do here. I like to be super plain where I give you like weeks ahead of time what all the worksheets are. I'm kind of going with the flow and using different things here and there from time to time, so kind of hard to do as well. All right, stunning video to start. Hopefully I'll cut all that out for those that have to watch it if they miss school. All right, what do we have? 22, 20, so I am missing people again. Oh, the absences. Okay, so first thing for sine, the amplitude. Well, we do have a 1, so it is 1. Now, wrong. What am I doing? What am I doing? I got to put that here, but what I have to do is actually clean this up. This pi over 2 does not belong on the inside of the parentheses. So sine pi over 2. And then what happens when I pull that pi over 2 out? What happens to this? I want you to think about that, maybe put your answer. Remember, your answer should make sense. It makes me so sad how many students don't do this. When I take this out, or when I put a number here, this times this should equal that, right? So that's what we got to make sure. When I put something there, does pi over 2 times that right back give me what I started with? All right, that should be enough time. High-level math students, not really. This is the grade school fractional concept. We should have got 3 there. Okay, now remember I mentioned that matching thing? Here's what I have a matching section, like 3 different ones. What you get is an equation. I'm trying to get my pen to work again. That's why you see my hand on the screen. Hey! All right, this would be the matching. Like you don't even graph it, but what you do is you answer these questions. Hey, what's the amplitude? What's the period? Is there a phase shift? What's the range? So the amplitude's easy. Or is it? You'll find out something today. This is the multiple choice question I don't like. And then the period. Okay, I forgot to do this. So A is equal to 1. Period is 2 pi over 2. Ooh. And then I'll do teaching fractions yet again. You can't say I didn't teach fractions this year. If you did, then you are really oblivious to what goes on in class. Okay? Because dividing by pi over 2 is the same thing as multiplying by 2 over pi. Weird. Don't be sticking pi's where they don't belong. The pi's canceled, so the period is 4, and I will tell you why this happens a lot. A lot of times the x-axis represents time, like in seconds or months. We're in a periodic situation right now coming up on the positive part. That's weather. Okay, so we were just down here for the weather. Now we're coming back up, and then by summer we'll be at the high point. And then when fall happens, and then so the x-axis over time, what happens with the weather? So that could be months, and that's why the period would be 4. The period for weather is 12, you know, right? 12 months. I mean, come on. Anywho, we do have a phase shift of 3, no pi in it, and it's 3 left. They'll be putting pi where it doesn't belong. And we'll talk about the range at the end. I hope I feel, well, you know what? You should be able to do range now. The amplitude is 1. That means it goes from 1 to -1, and there's no up-down shift. So you should be able to do the range without even graphing in the matching section. To know that the range is dictated by the amplitude. So those would be 4 matching questions on this thing, and you didn't even have the graph yet. So there you go. We'll ask you that, like 3 different graphs, 3 different times. Okay, this one dictates that you put the period off to the side. I don't have room off to the left, so I'll have to go to the right. Half of 4 is 2, half of 2 is 1. 1, 2, anyone, anyone, anyone. 3, Mr. Samuelus, 4. Those are the critical x-axis values before shifting 3 to the left. Now it says x plus 3, but we've been getting 3 to the left is subtract 3. So here's where my graph starts. So, hey, this would be easy to do 2 periods. Sometimes it is, sometimes it isn't. Do remember that 0 is part of the critical values. That was the hard shifts left and right when it wasn't, and people could mess that up. So that's just something to keep a note of. And then sine is, I didn't do something I was going to say, but it's all right. 1 and negative, I'm talking about 5th hour. I was going to come back and graph cosecant of this picture. 1 extra step. Man, I see someone's big hand in the screen. Who is that? I don't see their face, just a big hand came out of nowhere. I see like the very top of their hair. I love this. Good times in this e-learning environment. Oh, that's right. We're in the middle of a note thing. How does sine start? 0, high point, 0, low point, 0. And then here is sine. Full, full. And come on. 2 periods, 2, 3, 4, 5. I think that's all I need. High point, 0, low point, 0. This one I would not feel guilty at all of asking 2 periods. Remember what's key, marking the x-axis. If I have somebody come in the 15th, 16th, whatever those 2 days are, and you're not marking those x-axis values, you are in another world. At this point, you are somewhere you're on Venus and we're on Earth. Did I say good morning? Good morning, Aiden. I'm sorry. How could you start the notes without a generous and nice good morning from Mr. Samuelus? Aiden was sitting there like this. I'm waiting until he says good morning. Now, there you go. You're welcome. Oh, okay. What is this mess? Your notes look like crap, Mr. Samuelus. Couldn't care less. Wait till you go to college, man, and you got some old curmudgeon scratching at a board, chalk's flying all over, and you got to take notes and so on and so forth. So it'll happen. Guarantee it. All right. So here's what we got, though. Input, anyone? Input, anyone? Input, anyone? I saw you, Aiden. I saw Alexander. I think Amber said that, or she just swore under her breath. Oh, shut up. Yeah, she just shook her head. Yes, that's what I did. Nice. All right. So y equals sine of x. Okay, here's what happens. And this is what I want you to understand, screwing around all to the side here. You have to understand, I'm going to highlight what you're looking at because I know it looks like a bunch of junk. This is the inputs, and then we're going to graph sine, the outputs. We already know how to graph sine. I know. There's a point. This is our input-output chart that we started the year. And you know that the sine of 0 is 0 because sine starts as, the 0. And then at pi over 2, the high point. And don't worry about me having pi over 6 in the chart for the moment. Don't scratch it out. But I want to prove a point about what happens with cosecant with a couple values there. And then back to 0, and then the low point, and then back to 0. And then graph this as a dotted. Because what we're going to eventually do is graph cosecant, and we're going to use sine's graph in order to do so. So this is not the graph. We're graphing this. Lost my pen. No, actually, I didn't. We're graphing cosecant. So what we're going to do is input, output. Same input values, but what do I get for an output for cosecant? It's simple. This is probably the only time I'm going to ask you in the chat. I'm going to ask you two things. Let's try to get everyone to answer this because it's pretty simple. We know that sine and cosecant are reciprocals of each other. So the sine of 0 is 0. What's the cosecant of 0 if I just have to flip? So what is the cosecant of 0 if I have to flip this? 5 seconds. Don't write it yet. I lost my pen, so it's longer than 5 seconds. What is the reciprocal of 0 over 1? Okay, 5, 4, 3, 2, 1, go. Nobody wrote it. 6 hours? Have you been doing this lately? Are you on strike? Oh, no. I get a whole bunch of wrong answers. This is good, though. This is why I don't answer, Mr. S. Then I get yelled at for having wrong answers. Incorrect. Okay, now look at everyone putting in there undefined. And I bet you some people made some corrections. And I saw somebody, I read their lips. They said undefined, and I want this in green. Now, I don't have the time for this. You have to recall chapter last semester. Let's just put it that way. When we have undefined values for x, we either had two things. It was a hole in the graph, but more specifically, it was an asymptote that was vertical. So that's why you see this on the x-axis already. You have an asymptote there, so write it. And you know what? You have an asymptote here and here, because again, the reciprocal of 0 is undefined. Well, look at the picture. It's where the sine curve crosses the x-axis, because that's where y is 0. And therefore, the reciprocal of 0 is undefined and can emulate itself as an asymptote, and it does. Okay, and then one more time in the chat. Let's go faster than this, because this one's really easy. What is the reciprocal of 1? 5, 4, 3. Come on, just humor me. 2, 1. Go ahead. It ain't rocket science, folks. You can say whatever I want. I don't understand his teaching style. I don't know where you're at when you say that, because I try to break down everything for you so there's a high level of understanding of why what we're doing, why we get what we get, and then we move on. So those are shared between those two graphs. That is the beginning of the cosecant graph, those two green dots. Now it's time to bring out pi over 6, just as a learning concept. I'll never write pi over 6 again as a critical value, unless it's a period value, 1/4 of a period. So it's saying too much there. I'm not going to insult you on the chat. The sine of pi over 6, looking at this, is 1/2, because sine of 30 is a half. So sine of pi over 6 is like right there. I'll put that as a red dot there, a half. The reciprocal of a half is 2. If I just connect these two right here, then I got this going on. Because I tried to, the pen betrayed me. All these other values, you know, sine of pi over 4, sine of pi over 3 are closer to 1. The flip of closer to 1 are still closer to 1. The big deal is the flip of very small is very large. And then that is why you have that asymptotic behavior. These values flipped for sine. The smaller the value is, the higher the flipped value is. 1/10 flipped is 10. 1/100th flipped is 100. This is very simple mathematical concepts. And then the same thing here when I have 5 pi over 6. That's actually over here, sorry. That's 1/2. When I flip that, that's 2. So basically what you have is something that looks parabolic, but it's not. Flip of, here's 7 pi over 6. That's -1/2. Flip of that is -2. So on this side, you have this. Not belabor the concept too much further. There you have your secant graph. Sorry, cosecant. I knew when I said that was wrong. I'm going to put this in the chart. The flip of 1/2 is 2. That just denoted the idea that you take sine and you flip it, all right? And that's how you graph cosecant. You can't tell me cosecant graphing is hard unless you don't still know how to graph sine at all, which is a problem. Okay, now don't worry about this off to the side. I use this unit circle stuff in order to graph those critical values one more time. What I just went through should have been fine. But here's the situation that you may not like to start off. I want to list domain and range. Forget how they do this. Actually, now that I think about it, they do it a little bit different in the book. And then I'm going to tell you who domain is related to. We got a lot of problems with domain. We actually have a lot of undefined scenarios at every single asymptote. So x such that this notation right here, you should be able to read. And I'm not saying that. I think we at Lockhart leave it and only do interval notation. But then if you got a certain book, they might use what's called set builder notation, which all this says is here's the domain. It's all x's such that. That's all that this line means. It's not a big deal. And then we need an inequality or an equation. In this case, it's an inequality. That's the best way to express this. To say x, the domain is everything but, that's what a not equal to sign means, where the asymptotes are located. And the first one's at 0. Now this gets into what I covered in class last with the cosine, the cosine worksheet on the back, naming all answers. How far away are all the asymptotes? I want you to think about that for a second. I'm not going to bother you today. A college professor lecturing, you get to bounce around and look around if you're taking notes or not. If you're not taking notes and you fail, you'll just pay for the class again. So I'm going to leave you be. Do nothing back there, go ahead. Most of you are, though, so that's a good thing. All right. What's the answer? How far away they are? Don't put it in the thing. We don't have too much time. Pi n. So that's what I was covering with you the last class, building on the idea of naming all of them, right? So 0 is the first one. Do you really need 0 there? No. I just wanted to make sure you understood that starting 0, that first asymptote, then every other asymptote is pi n away. By the way, that's half the period, isn't it? Just remember that. That's how far the asymptotes are always in these. Because you got a period, but in the middle there's an asymptote to separate the two u's. Right? You know what that is then? That is actually 100% related to the equation of the asymptotes. We are going to ask you this. Matter of fact, in the matching, this may come up. You know, so you have to have an idea what the period is and then know that the period, half of that ends up being what the asymptotes are, or we'll have you write them down. Now, why does it say x back? Because these are vertical lines. And I've taught you all year long that the equation of a vertical line is x equals a number. Whether we have that memorized or not is up to you. And you know what? Same answer, what the domain issue. The domain issue is the asymptotes. The asymptotes are where the graph does not exist, right? So that is why those are synonymous with each other. And then notice the range difference. I'm not going to spend this much time in cosecant because the ideas are established. These are the y values covered, not in between 1 and -1, right? So the range is completely different for cosecant compared to sine. It is everything but between -1 and 1, still including -1. Yes, that was a mistake. Anyone that wants to jump on that. That's a parenthesis. This is a bracket. I had bracket on my brain because 1 and -1 are still part of the graph for cosecant, but it's everything else but between. It's everything past that's covered. That's why we write it like that. Okay. Like I said, for secant, the whole extrapolation idea is set up. The word extrapolate means we derive and make sense out of, so it's easy, makes sense. Now we got the idea of how to extrapolate this, so we'll graph secant. Okay. Input, output. Okay, and then we're going to go ahead and fill in these missing parts that I lost in my eraser. So for graphing graphing cosine, the parent function, goes 0 to 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Oof. Really shows me somebody that if we can't get these four, you've seen this in our notes probably like 10 times already. Urgh. This is the kind of junk I'm getting, though. That's the demoralizing part. Does wear on me. All right, the cosine kid. Okay, cosine kid, karate kid. Now, why a dotted line again? Because I want to graph secant, not cosine. This is not part of the graph, but it helps me. Just like the asymptotes. The asymptotes are not part of the graph, so I graph them as dotteds, not solids. General rule. All right, and then we can ask the same annoying questions. What's the reciprocal of 1? The answer is 1. What's the reciprocal of -1? -1. What's the reciprocal of 1? 1. So at these positions, the graphs share a coordinate. Cosine and secant share those two coordinates. 3. Sorry. And then what's the reciprocal of 0? Yet again, it's undefined and undefined. And we just remembered, I'm not going to say learned, we remembered one of the possibilities, and it definitely is that possibility, that at the zeros for cosine, it's actually asymptotes for secant. Undefined is asymptotes. And then it's the same thing. The smaller it is, the reciprocal of that, the bigger it becomes. That's why this approaches this asymptote. Negative small is negative big. So this approaches. It's like the easiest thing to graph secant, cosecant. You just have to graph sine and cosine and flip. I think I said that at the beginning of class. We had a 4-1-4-2 quiz. We would do it after this lesson because this is a nice review of how to graph sine and cosine anyway. All right, and then not to go too fast on you here, I skipped domain on this one because, you know, the domain is what the equations of the asymptotes become anyway. So I think we're good with that. Equations of the asymptotes are x equals because they're vertical lines. This is really what would be in your matching section. And actually, you physically will have to graph on the test or quiz coming up. We are going to ask what are the equations of the asymptotes too. It's going to be a definite question. Now, the first one's at pi over 2. So this one's a little different. You got to get your starting point. And then, yes, they are half the period away from each other. Or you can figure out that distance from here to here is pi. I hope you can, fractionally. So many things that fractions kill cats. And then negative infinity to -1. Don't have the time, but I feel like a great idea would be go back to those grade school fraction rules like a whole week, right? And it really does train without a calculator. That's the thing. Really true. All right. Again, just stalling so that get all this stuff down. Doing a hair check real quick. I do my own haircut, and then sometimes during these videos, I'm like, oh, I missed a hair right there. I have to go upstairs and shave that off. Yes, I do cut my own hair, whoever's wondering. Done it for 20 years. Think about all the money I've saved. Some people say, you overpaid for it, Mr. Senior. Just shout out how bad my hair looks. Okay, so here we go. So what's the overall rule of graphing secant or cosecant? Graph the corresponding sine or cosine, flip. You know, and you don't really need to see it in the chart. No, we're not making a chart. By the way, this is just, you know, good to know. Oh, I hate using that term. That was something that we used last year, but we're not going to test you on this. But remember sine's odd. This is a reflection sound. Odd means symmetric with respect to the origin. You know, cosecant's related to sine, so cosecant's also odd. And then sine, wait. That's over the x-axis. That means cosine's even. So is its brother or sister secant. Okay? Good to know. Nice to know. Thank goodness we didn't ask that on the test. Hope not. I don't think so. Okay? Good enough. You want to write that, it's still visible up there. We're going to go ahead and graph this. This one's actually going to be easy because there's no right-left shift. We can go right to the graph after we label our parts. We'll talk about domain in range, sorry. Yeah, domain and asymptotes. All right. So, oh, by the way, write this down. This is a jerky question. Remember I told you there was a question on the test I really didn't want on there? And they put it on there anyway. So go ahead and write this, and then it's just a matter of you remembering this. They ask which graphs have amplitude or which graphs don't have amplitude, one or the other. The idea of amplitude is like the cycle, like the weather has amplitude, and give or take whatever winter and summer is, the high is usually right around 100 on a random day, and then the low is usually like -20. So that's the amplitude of that's the high and low points. There is no high-low point in secant and cosecant, and there is no high-low point in cotangent and tangent, which you'll find out. So there is no amplitude for secant and cosecant ever. But we do want to mark an A value so that we know what the, I don't know what I'm trying to write there, where it starts, what the range is. But we are going to say, this is what's confusing and kind of jerky by the math teachers, but we are still going to call it an A value, a stretch shrink factor. All right, so it's not amplitude in the sense of what happens with trig. I know you're probably not going to like that, but it is what it is, and you just have to accept it. You get what you get, and you can't. Anyone? Some people throw fits all the time. My Math 2 honors, some are, and their parents, because gosh forbid I actually expect them to do homework and do their work and come see me if they have problems. All right. Let's do this. Let's go right to the graph. All right, and then notice I went over that really fast, but I hope the heck you know 2 over a half is 4 pi. Dividing by 2 is the same thing. No, dividing by a half, sorry, is the same thing as multiplying by 2. All year long taught that. Now, I know we saw that 2 there as a value. You don't have to go 1, 2. I don't care what A is. You can just put it right there. There you go. And it's just a mark that you know what the A value is, so you know what your range is going to be. All right, and then this is an easy one. Oh, man. 4 pi. Half of 4 pi is 2 pi. Half of 2 pi. Oh, come on. I don't even have fractions. 1 pi, 2 pi, 3 pi. And then for 2 periods worth, this is what we're going to ask you. It's like easy. You just cut and paste. All right. Okay, so then here's the other thing from chapter 1. Don't be jacking this up. Secant is related to cosine. If we're still messing this up, there's nothing I can do. At this point, we've done so many things, so many different homework assignments that has talked about that relationship to not know that at this point. And then there are no right, left, or up, down shifts. So we're ready to graph cosine. Hey, yeah, cosine kid. High point, 0, low point, 0, high point. Same thing over here. All right, and then it's a dotted line. Okay, and then you don't have to look at a chart for this. The reciprocal of 0 is undefined. You don't need a chart for that. That's what that y value, that's why I've been doing input output all year long, to be able to read a graph and understand what the y values are, what the outputs are. The output here is 0. The reciprocal of 0 is an asymptote. Wherever there's a 0 for cosine, it's an asymptote. We're now past the extrapolation stage. We are now in the doing. What this all means behind the scenes. Ooh, that rhymed. Poets. Didn't even know it. Now, I know what a real high-level student might say right now. 2. Do I have to, I probably shouldn't even say this because this would be the most random of people that would think this. But it is a high-level set of thinking. Is the reciprocal of 2 1/2, so to start secant, do I have to go down here? No. Order of operations. The secant of 0, that would eliminate that half. The secant of 0 is 1. What's 1 times 2, everybody? 2. So whatever this value is here, they, because of order of operations, will always share it. All right? And it's because of order of operations that's the case. So if you had that question, probably not. If you understand why a student might have that question, great, but it doesn't happen. Right? So you basically, wherever the high and the low points are, that's the starting points for cosine's graph. I'm sorry, secant's graph. You like that thought process, though. It's actually some high-level thinking there. Order of operations says, no, that's not what happens. So that's it. That's your responsibility. 1 extra stinking step. Zeros become asymptotes, flip the others, and they share that high and low point. But off to the side, we are going to find our right domain one more time. Now that I think about it, they do something really weird with interval notation. I don't like interval notation for this. The domain is what x can equal, and therefore can equal everything else. That's what a not equal to sign means. Pi plus half the period n. That's the generator. These are all 2 pi away from each other. That's why we write that 2 pi n, just like we did on that cosine sine worksheet. And then the domain means the asymptotes are exactly that with an equal sign, because asymptotes are vertical lines and they are in that domain problem situation. They are the domain's problem. So that's why they are the same thing, but with an equal sign. Please don't write the asymptotes with a not equal sign. I hope you understand what a not equal to. X can equal that for the domain, but that's the equation of the asymptotes, equal. Then the range is different. We went from 2 to -2, but we didn't. The graph covers everything but 2 to -2. Well, including 2 and -2, though. Those are shared values. So the range gets split in the opposite direction. Okay? That would be in the... I got multiple choice stuck in my head. Matching. Couldn't get the word matching out of my brain. That's why I stopped there for a second, frozen. All right, moving along. Ready to go? Everyone all right? Drives me nuts. Google changes. Update is another downgrade. Just don't like how I see the class anymore. I don't know why they had to do that. You can only see about half of you. Turn the chat off. Thanks, Google. I hope you're listening. You ruined it. Ruined it for us teachers. Go ahead and come after me. Dan Samuelis. My address is... Well, I can't do that. Then the students will know. Then they'll egg my house. Throw toilet paper on my trees. I shouldn't tell you the story, but I did have someone throw a brick through my car window back in the 90s. True story. I've been popular forever. All right, here we go. I don't lie. But anyway, 2 pi over 1. We're only going to graph one cycle when we have right left shifts. But then I'm going to back off on that because it's actually, this one ends up being easy because the way the phase shift works with the period. But we hopefully we see that there's a 1 there. There is no other stuff going on except for, phase shift right. phase shift is pi over 2 to the right. All right, so this is one where we have to do our work off to the side. Okay, well, we got our ordinary. This is what I mean about if you don't know when the period's 2 pi, get these values. This is probably, I don't know how many times we've seen this. Really am questioning that. Can't do that. It is a problem. Okay, and then, you know what? I'm just going to add pi over 2 like this all the way down because this ended up being real nice. These mesh really well together. So I'm going to start, I'm actually going to start the sine curve because sine's related to cosecant by flipping at pi over 2. And then what's pi over 2 plus pi over 2? Pi. And then, okay, oh, I see this. These all, this is 1/4 of the period. So these just all get shifted, and it's going to be these. Or I could see the pattern. 5 pi over 2. Okay, so now, okay, fine. I'm going to go to my graph. I said I was only going to do 1 period. I'll talk about how 2 periods isn't hard. I just get worried when the period and the phase shift don't mesh together. I don't want to fractionally make someone's brain explode. 0, and then pi. Well, that's easy. That was actually really easy. So what I really like is making sure that your distances are pretty cool compared to anything else. And this one's actually pretty standard, pretty easy. So real nice right-left shift with the period. There's where you're going to graph sine. Okay, now what's our amplitude? Who cares? Just make sure that you, when you think about the range, sorry, having a hard time grabbing words right now. Range, know that affects the range. What I mean is if it was 7, don't go 1, 2, 3, 4, 5, 6, 7. Just put 7 right there. Who cares? Right? And then graphing sine. Sine starts at 0. Then high point. Not flip. Careful of flips. For some reason in the notes I missed a negative out in front. If it's a negative out in front, then it starts below, and above. You should be able to handle it. And then if you need to draw the dotted, fine. If not, if you get it, then go ahead and start your flipping. Okay, wherever there's zeros, those are asymptotes. If you don't have to draw the dotted line cosine or sine, depending on what the question is, don't. Because then you understand that they share this value no matter what it is. Oh, and then they look like this. So I can see that you don't have to draw the dotteds. Get this figured out at this point. And there is your classic cosecant. Couple bowls like that. Okay. Okay, and then you could see if I wanted to do another one, which I'm not, but it would just be pi over 2 left. So that'd be 0, negative pi over 2, negative pi, negative, and you could keep going. It wouldn't even be that big of a deal, but we're not. Okay, let's get that period wrong. Let's get that domain. Let's just do the asymptote. The asymptote is what the domain issues are. So really what we're going to ask you is the asymptotes. X equals, and it's at pi over 2 for the first one, and half of the period is pi. I mean, I'm not doing a robotic formula there. Oh, I got to memorize that it's half of the period away from each other. Just look. That is a distance of pi. That's how far away those are from each other. And then the range is pretty simple as well. Negative infinity to negative 3/2, bracket, union that with 3/2 to infinity. This would be a perfect matching thing. We have a big jumble of answers, and then I'll ask, what's the range? And kind of going to stick out like a sore thumb with, how the range looks, and we'll have a couple of distractor answers and so on and so forth. So, all right, and then this is the last one, and it should be. Hope you're really focused. Like I said, I think I said it in this class, maybe it was first hour. The first word of this class is college, algebra trig, right? So when you go to college, if you go to a big one, you're going to have some ugly curmudgeon of a professor scratching on a board with chalk flying around, and you're going to have to be like writing notes. And Tuesday, Thursday classes I used to have, and they were an hour and a half long. Monday, Wednesday, Friday for a 3-hour course. That was about an hour, 5 minutes maybe. Oh, and then night classes. Whew. Those are like 2 hours and 45 minutes of just listening. Good times. All right, this one we're going to go right to the graph because what's the amplitude? And you should yell none because there is no amplitude for secant and cosecant. You're going to hate that question. What's the period? Okay, fine, we have a different period. It is 2 pi over flat out 4, so finally we do get a fractional period with pi in it. And then the other thing is we have down 2. So actually this is one where happily we can go right to a graph. So this will be a fast one. There is no right-left shift, that is why. Since there's no right-left shift, we can talk about a second period. I guess I'll draw it because this one's easy. It's a cut and paster. And again, the fractionally challenged cannot get this. It does make me sad. It's a high-level math class, seniors. Okay, so please embrace my fraction abilities. Half of pi over 2 is pi over 4 because all you do is multiply 2 by 4 on the bottom. Half of pi over 4 is pi over 8 because you just multiply the bottom by 2 to take half. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 4 pi over 8. Is that 4 pi over 8? Yes, that's why that has to be 3 pi over 8 in that position. Not what I hit. Okay, there we go. All right, and then cut and paste. Fraction dilemma. I don't know what happened. Why fractions are such an issue. Got no answer for it, man. Although I do try to teach it all the time. Go through the processes of what you should be in your brain. Shut up, Mr. Sam. Okay. Now, hey, it's from 3 to -3, but then it goes down to. This is the questions I'd ask in class, but you know what? Because of time, we're just going to go with it. Your new high point is 1, because it was at 3, but it's down 2. -3 goes to -5. -1, -2, -3, -4, -5. Oh, one more smart thing. Oh, no. It is going to be right through my values here. And then it could look like a negative on some of these. So be careful. But this is my new x-axis. So guess what? This is where the asymptotes exist. It's because of order of operations. Here, I'll make it simple. What's undefined minus 2? It's still undefined. Okay, so that is why wherever I get my zeros where they're supposed to be located, that is still where the graph behaves asymptotically. So that's all I can say about that. And then it's over. Secant is related to cosine. And it does start here because there is no right-left shift. So high point, 0, low point, 0, high point. Samuel is dying during the notes. 0, low point, 0, high point. That wasn't COVID. I just something in my chest there for a little bit. Okay, and then asymptotes. So I start here. That's where the asymptote is at pi over 8. Ooh, I don't know if I said that asymptotes. No, I think I did. Asymptotes. 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 So it's kind of hard to find. Make sure you don't lose where those new asymptote values are. And then shared up. Shared down. Simple Simon. Shared up. Shared down. So we did 2 cycles of this. 2 periods. Right? And that's good. Okay. Then real quick to end it. Not domain. Let's just do asymptotes. If you forget x equals, I'm marking you wrong. That's always since first semester. It's an equation of a vertical line, so it's x equals a number. No x equals, you're gone. All right, and then it's x equals the first one, pi over 8, plus, okay, how far away are these? Well, the period is pi over 2, so they should be pi over 4 away. And they are. This is a distance of pi over 4 from there to there. A little tougher to think about, but it is. then do be careful on the range. It could have been above and below 3 and -3, but everything's moved down 1 or 2, down 2, down 2. So looking at this, it's -infinity to -5 with the bracket. And then you union that with 1 to infinity. Those are great matching questions. And you should be able to do that matching without even graphing. You should know secant does this. Okay, 3 to -3, down to, okay, yeah. So above 1 and below -5. Got it. Matching. No, you shouldn't even have to graph this in order to think about what that is. You know, and I hope that, I know you just learned it, but I'm just saying by a week from, what's today? Today's only Tuesday? Oh, I don't know if I'm going to make the week. Anyway, I'll end on that note. Been a rough week already.